slope-intercept form of a line. This is going to be a nice little shortcut to graphing equations. This is slope-intercept form, y equals mx plus b. X and y are just unknown variables, any ordered pair. M is the slope of the line, and b is the y-intercept of the line. So if we can get an equation to look like this, we can very quickly identify the slope and the y-intercept. So here we go. Let's do a little bit with this. Which of the following equations is written in slope-intercept form? So we got x equals 2y plus 3. No, because we're trying to get the y by itself on the left. This has the x by itself. B, y plus 2x equals 3. No, again, we're trying to get the y by itself. And C, that's our answer. Y equals 2x plus 3. So we got the y by itself, then everything else over in the right, mx plus b. So B, what is the slope and y-intercept of the graph of this equation? And this equation is in slope-intercept form. Y equals m times x plus b. So m is our slope, and that is negative 1/3. So our slope here is negative 1/3. And our y-intercept is right here, this plus 2. If it was minus 2, our y-intercept would be negative 2. So going back up here to example A, the slope is 2 of this equation, or 2 over 1, and the y-intercept is 3. So let's write equations for lines C through F in slope-intercept form. So we're given some lines, and we're going to write equations of those lines. So what about line C here? We need to know two things. We need to know the slope and the y-intercept. Well, for line C, we can first of all tell that the slope is 1 over 1. 1 over 1 is just 1. So we're going to start with y equals x. We're not going to put 1x. We could. We're definitely not going to put 1 over 1x, and we're not going to put 1x, so we'll just leave it as x. There's a slope of 1. And then the y-intercept is 6, so plus 6. All right, how about D? D has an undefined slope, and its y-intercept is 3. Okay, it does not go up at all, so it's like a slope of 0, and it's got a run of 1. 0 over 1 is 0. So we wouldn't put 0x. We'd just put nothing. But the y-intercept is 3, so we'll just say y equals 3. 0 is the slope. 3 is the y-intercept. We'll just simplify that, get rid of the 0x, because anything times 0 is 0. How about E? I see a slope of down 1 and over 2, so that's a slope of negative 1/2. So we'll go negative 1/2 x, and a y-intercept of 1. That's where it intersects this y-axis. And for F, see it's got a slope of negative 3 over 1. So negative 3 over 1 is just negative 3. And it intersects the y-axis at negative 3, so minus 3. Don't put plus negative 3, just put minus 3. So negative 3 is its slope, negative 3 is its y-intercept, negative 3x minus 3. All right, and then we're going to do the opposite here. Now we're given some lines that are in slope-intercept form, some equations of lines that are in slope-intercept form, and we're going to graph the equations using the given slope and y-intercept. Well, the slope and y-intercept aren't flat out given to us, but we can quickly determine them. For instance, on G, the slope is 1, and the y-intercept is negative 2. So we're going to start by plotting the y-intercept right there, negative 2. And then we're going to use the slope from that point. So from this point, we're going to go up 1 over 1 because that's the slope. And we can continue going up 1 over 1 if we want. That way we'll make sure to get a nice straight line. We can also go down 1, left 1. Negative 1 over negative 1 is also 1. And then I don't even need a straight edge. It's really easy to make a nice straight line. And that line represents every single ordered pair that works in this equation, x minus 2. So equals y. So 2, 0. 2 minus 2 is 0. 3, 1. 3 minus 2 is 1. 4, 2. 4 minus 2 is 2. All right, how about h? The slope, or m, is negative 2, and the y-intercept, b, is 4. So we'll plot that y-intercept, and then we're going to go down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1. Keep doing it. Repeated slope there. It's a constant rate of change. There's our line. And the last one, our slope is 1/2, and our y-intercept is negative 2. So we'll start there at negative 2, and then we're going to go up 1 and over 2, up 1 and over 2, up 1 and over 2. That's the same as going down 1 and left 2, down 1 and left 2, down 1 and left 2. And then we can draw a nice straight line there. And again, this point represents every point that is a solution to the equation. So negative 6, negative 5. Half of negative 6 is negative 3, and negative 3 minus 2 is negative 5. One more time, about 6, 1. Half of 6 is 3, and 3 minus 2 is 1. So every point that's on this line, including in between the points we plotted, will solve this equation, or make this equation a true statement. Okay, so slope-intercept form, very quick and easy way to graph lines and write equations for lines given a graph of a line. We'll see you soon.